Daniela, and Elena are proud to present our science experiment. Our experimental question is, does pH affect the process of electrolysis? Why did we choose this project? We chose it because we were interested in electricity. And when we started researching about this, we found out about electrolysis. And from this, we developed this experimental question. So, what is electrolysis? Electrolysis is the process in which chemicals are separated when an electrical current passes through them. There are important laws about electrolysis. We researched about the two main ones. The first one was stated by Michael Faraday in the year 1832. He said that the quantity of the compounds that broke down into two from the electrical current was relative to the quantity of the current that passed through the circuit. In the second law, he noticed that the weight of the different compounds, including hydrogen and oxygen, are always equal to the weight of the divisor, the electrical current.
So, what happens during the process of the electrolysis? Electrolysis is an electrochemical process in which current is passed between two electrodes through an ionized solution or an electrolyte. It deposits positive ions or anions on the negative electrode, the cathode, and negative ions or the cations on the positive electrode, the anode. This occurs because the positively charged ions receive electrons and they are reduced, and the negatively charged ions lose electrons and they are oxidized. Two gases are produced during the process of breaking the ionic solution into simpler substances, oxygen and hydrogen. Hydrogen is executed by the positive terminal and oxygen by the negative terminal.
Another key term to apprehend when carrying out this experiment is pH, which is the measurement of how acidic or basic a substance is. An acid is a substance that donates hydrogen ions. When an acid is dissolved in water, the balance between hydrogen ions and hydroxyl ions is shifted, ending in the result of more hydrogen ions, creating an acidic solution. A basic is a substance that accepts hydrogen ions. When a base is dissolved in water, the base soaks up the hydrogen ions, resulting in a larger amount of hydroxyl ions, creating a basic, or also called an alkyne solution. The pH scale varies from 0 to 14. A pH less than 7, including vinegar or lemon juice, is acidic, and a pH more than 7, like laundry detergents, is basic. 7, which is pure water, is described as neutral. A strongly acidic solution can have 100 million more times hydrogen ions than a strongly basic solution. To cope with these large numbers easily, scientists use the logarithmic scale, or the pH scale. pH is the negative logarithm of the hydrogen ion concentration. This equation signifies that for every 1 unit change in pH, the hydrogen ion concentration changes tenfold. To measure the pH of an aqueous solution, one can use an indicator or a glass electrode.
For our variables, we have our independent variable, which is levels of pH. Our dependent variable is the amount of gases. The level of pH controls the amount of gases. The constants are, we will always use the same tubes, the same amount of water, the same amount of pH, the same amount of time, and the same amount of voltages. The control is the not manipulated pH water.
So, our procedure. First, we will change the pH of a certain amount of water from 2, 7, and 14. Then, the electrolysis process will occur, in which current will be passed through an ionized solution. And then we'll measure the amount of gas released, the oxygen and the hydrogen.
Regardless of the science fair experiment, electrolysis is used in the real world. For example, hair removal uses electrolysis. There is also electroplating, which is when you cover an object in materials such as copper, gold, or silver.
This is your bibliography.
Thanks for your attention.
Any questions?